In this lecture, we learn about DNS. This is the subchapter number 2.4 in this chapter 2. After that, in this lecture, we learn about 2.5 subchapter, that is about peer-to-peer applications. First, let's look at this DNS. DNS means domain name system. Think about some analogous example to understand better. In our case, people, we are using many identifiers. For example, social security number in the United States. Also, even in Korea, residential number, we are using that. And also your name and also passport. Those are all different kinds of identifiers. Let's move to the internet world. What kind of identifier will be used? Here in this internet hosts or routers, they are holding IP address. That IP address is 32-bit. Later we learn about that. Actually, that is defined in the network layer protocol, and we learn later in the following chapter. And this IP address, that is used for addressing datagrams. We are sending some packet or datagram that is carrying some identifier, that is IP address. But we are using, before that, usually we are very familiar with this domain name instead of that numeric IP address, because humans are very familiar with this name instead of numeric number. Thus, something should change that domain name to proper IP address. For example, if you are using google.com, then that DNS is actually changing. DNS server is changing that google.com's domain name to the google.com's IP address. Then how to map between IP address and the name and vice versa. And the following slide is explaining about that. Okay, domain name system. That is a kind of database, and that is distributed database because that is spread in the world, implemented in hierarchy of many name servers, and that is belonging to the application layer. Thus, this DNS is a kind of application layer protocol. And host name servers communicate to resolve names. If even your smartphone is interacting with that name server, finally you will get the proper IP address for that specific domain name. After that, we can send IP datagram and packet. That is called resolution or reserve names. That means address name translation. That is a kind of resolution. And this is a kind of core internet function and implemented as application layer protocol. And that is complicated and complex at network's edge. And if it is not working, we cannot use that internet if we don't have the proper IP address for that specific domain name. Thus, we should study a little more in detail about this, about services and the structure of this DNS. DNS services, host name to IP address translation, and the host aliasing. For example, canonical name and alias name we can use. Think about alias name, www. We are very familiar with that alias name, www. That is a kind of alias name, simplified. instead of the full canonical name, because this DNS is providing that service also. Also, mail server aliasing, instead of the very long canonical name, we can use a simple name for that, use this aliasing. And also this DNS is doing this kind of load distribution, and the replicated web servers with many IP addresses correspond to one name. There's implicitly that load will be distributed because many IP addresses are providing that service, and each IP address is taking care of server, and that means many servers are providing that service. That is called load distribution. For example, later we'll look at tutorial command to look at how many different kinds of IP addresses are being used, even for the google.com single name. That will be used for load distribution. Then, why we are using distributed instead of the centralized DNS? This one is asking, why not centralized DNS? If that is being centralized, then this is the drawback or disadvantage. Single point of failure will be serious, and traffic volume is so huge. Thus, we need distributed architecture instead of this centralized scheme, and the distant centralized database. And in terms of maintenance, there may be some pros and cons. That means there may be some disadvantage or advantage in terms of maintenance. Anyhow, we are using distributed architecture instead of centralized architecture for this DNS service. And the main disadvantage of the centralized scheme is it is not providing scaling. It is limited in terms of the performance and in terms of the service scale. Thus, we are using distributed architecture, distributed database for this DNS. Then, as we learned, this one is distributed, and that is hierarchical organization like this. There may be several different kinds of level here. Top level, that is root DNS server, that is called root DNS server, and this one is holding many children here. .com DNS servers, for example, we are very familiar to this .com because these .com domain names are huge and larger number comparing to the other .net or .org. And the .org DNS server or .net DNS server, .kr and .edu and so on. And also this one, .com DNS server may hold this yahoo.com DNS servers because this is .com. There's many domain names, .com domain names, for example, yahoo.com, even yankim.com, even wopen.com. We are using that domain name, or wopen.net. Those are related to that. This is called the top level domain, and this .com server, and that is maintained, managed by the VeriSign, and this one is maintained by the managed by ICON, and ICON is providing some authority to provide this kind of service, and some payment should be paid because that internet technology is being developed. That was actually developed by United States and government, and US government is holding that authority. Okay, and many other top level domain names here. Many other, even though those are not shown here, .kr, .net, or many others, or even .tv. Those are hidden here, but they are these top level domains. And think about this one. Client wants IP for this Amazon.com or Google.com. Think about the client. Yourself can be client, and you can request IP address for this Amazon.com or Naver.com or Google.com. For example, one client wants to get IP address for World Wide Web Amazon.com. The client needs to get the IP address for that. And the server, local server, that will be used for that, but let's follow this one. Client queries root server to find .com DNS server. Even though this is .com, but actually that is called .com DNS server, and that should be asked to the root DNS server, because those .com, .org, .kr, .edu, those are all listed in that root DNS server. After that, client queries .com DNS server, asking this one to get Amazon.com DNS server. This one is this database, .com database. This one is holding Amazon.com DNS server, because that Amazon.com, that domain name is registered here. And client queries then Amazon.com DNS server to get IP address for this Amazon.com. There's, you can see hierarchically, first root server, after that .com server, and finally this Amazon.com server is containing that IP address for that. And this Amazon.com DNS server, that is maintained and owned by this Amazon.com. Also this Yahoo.com, that is listed in this database DNS server, and that is maintained and administered by this Yahoo.com company. Let's look at next one. The first one is root name server, and root name server, that is located hierarchically on the top and contacted by local name server that cannot resolve name. Local name server we'll look at later with some animation. We can understand better, but before that, if I am explaining about this related to our university, in that case our university is maintaining and administrating this local name server, and here root name server, those are distributed in the world. And the context authoritative name server if name mapping not known, and this one is contacting authoritative name server. I will explain a little bit more about this authoritative name server. This authoritative name server, that is owned and maintained by this Amazon.com. In the previous example, that database, DNS database, DNS server, that is called authoritative name server. Anyhow, we'll look at that a little more in detail later. After that gets mapping. Mapping means the domain name related to that IP address, we'll get the IP address for that, and returns a mapping to local name server. This local name server is providing to the client that IP address. Here, local name server is distributed in the world. Here, 13 logical root name servers worldwide, and meter name servers are also located in many places. Each server replicated many times. Mainly, those are located in the North America, but also in the European area, also here in Asia, Japan, also in Korea we have probably meter root name server. Let's look at the next hierarchically next level server, and that is called TLD, top level domain. And authoritative server we'll look at first. Top level domain, that acronym is TLD. Those are responsible for .com, .org, .net, and so on. And all top level country domains, for example, UK, FR, KR, network solutions maintained long time ago these servers for .com TLD, but since the year of probably around 2000, VeriSign is maintaining these .com servers, and the other company is maintaining also the other top level domain, .net, .org, and so on. And ICANN has the authority to provide that authority to that company to maintain, and we'll look at that later. And the next one is hierarchically authoritative DNS servers. This one is owned by the organization or company. Organizations own DNS servers. This one is providing authoritative host name to IP mappings for organizations' name hosts. Thus, real mapping data is stored there, and this one authoritative DNS servers can be maintained by organization or service provider. And hierarchically, local DNS name server, this one is not belonging to hierarchy, and in terms of the iteration to find out the IP address for the specific domain name, that will be used for temporary DNS database. Each internet service provider, for example, residential internet service provider, company, or our university, is managing and administrating this local name server. Thus, we should provide that local name server IP address when we are trying to set up the IP setting. Also, this one is called the default name server. At least one, and alternatively, we can provide another one usually. When host makes DNS query, a query is sent to its local DNS server. And the first one, in terms of the DNS resolution, this local name server is the first server. This one is serving to find out the proper IP address for that specific DNS domain name. And this local name server has local cache of listen to name to address translation pairs. But sometimes that may be out of date, then that will be expelled from the buffer memory because that is limited buffer size. And this one is acting like a proxy and pour this query into hierarchy if it doesn't have that the IP address for that specific required the domain name, then it is asking hierarchically, and there will be some animation, and I'll show you later. And this one is one example for that, how this domain name that is reserved to serve and to find out the IP address for that domain name. For example, hosted CIS here, poly.edu. Once IP address for gaia.csumas.edu, and this one. Think about this one, and even smartphone, it doesn't matter. You are here and you are trying to put in this address, domain name, and to find out some web page, but before that, that IP address that should be reserved first. This one is explaining about that, how that is being reserved. Here, this one is asking to the local DNS server, usually in the same organization, same institution that is maintained and administered by the people in the same organization. This is iterated query. Contact this one. Let's follow this one and look at this sequence number. Contacted server replies with the name of server to contact. I don't know this name, but ask this server. And if we doesn't have any information about that, then first it is contacting root DNS server. And this one is providing some information about .edu. That is top level domain. Hierarchically, root is the top. After that, this is second one, but that is called top level domain. .edu, .org, or .com, .net. Those are all top level domains. And this one, TLD DNS server, this one is holding some information about this next, hierarchically, next level authoritative DNS server information there. And this one is provided to this local DNS server about that information. Actually, that IP address, and that is given to here, and this one is asking to find out the next level. Top level domain DNS server is holding the information about the second this one, umass.edu, and this one is holding that information. This is called authoritative DNS server, and the actual real data is stored here in this database. That is DNS server. That is called authoritative DNS server. This one is holding the information to find out this one, and this one is holding the information to find out this one hierarchically. This hierarchically, this one, after that, this one, after that, this one. And this one is finally being used to get the real IP address for that specific dns.cs.umass.edu. And that is given to this local DNS server. Then finally, this one is completing the resolution. After that, this one is providing the IP address for that specific domain name, URL. Finally, then this one is using that IP address to go to the next procedure to find out the web page and to get that information. Before that, this one should reserve that IP address for that specific domain name or URL. Okay, another way. This is called recursive query. Previous iterative query and recursive query, those are being explained with some animation. Later I will show you in the supplementary website. This is called the recursive query. This one is putting burden of name resolution on contacted name server. This one is assigning the task, and this one is assigning the task here, and finally like this, assigning. Then this one is solving that. After that, this one, the solution will be given to here and given to here, given to here in that way. Heavy load at upper levels of hierarchy. There's those task is given to the next one, and finally anyhow this one is providing that information. But think about many local servers are being serviced, and this root DNS server should take care of them. Then burden is so serious. And to complete the resolution, this one should hold that information. After completion of that resolution, that name and some information is released later. But anyhow, in that sequence, it is going deep and into more depths in that way, and in reverse way that is given to the previous server, and finally this local DNS server is anyhow providing that final IP address to this requesting client. Anyhow, we look at the example using animation in the supplementary website. I'll show you later. And here we will learn how to cache and how to update the database records. This one is containing the IP address for that. Once any name server learns mapping, it caches. That means it is buffering that information. That is called mapping information. Cache entries timeout. Sometimes that will be released and disappeared and expelled from the cache memory because that is limited size, and many other name mapping data should be there. Thus after some time, that is called time TTL time to live. Time level domain servers typically cached in local name servers. Usually this information, time level domain name, time level domain servers information, IP address, those are being used heavily. Thus those are cached in local name server because that is being used frequently. There's root name server that is not required to visit, and the burden will be lessened because this local name server is holding that information. Cached entries may be out of date. Sometimes that may be changed because some domain names IP address that may be changed because of the new movement or new web site or relocation of the server. Then IP address that can be changed. There may be many other ways, many other reasons, and anyhow that may be sometimes out of date. If name host changes IP address, may not be known internet-wide until all details expire. Then previous obsolete data will be stored in the local name server and the intermediate name server until this TTL time to live. That is like 30 minutes or 1 hour. 2 hours like that. Until that TTL time, that will be still remaining there. That is obsolete mapping data. Thus, that should be removed after TTL time. Update and notify mechanisms provided the Internet Engineering Task Force, that is standard body. And the standard body is working with this request for comments working number. Let's look at a little bit more in detail about that database record. The record is containing several fields. Let's look at this DNS records. This is database, thus we need record. And this record is holding several fields, and we need to understand the format and the syntax of that. As we learned already, DNS means distributed database, storing resource records. And this record is holding some IP address and some information for that. The format is like this. Name, this is called domain name, and the value, and the type, and the TTL. And here type is A. There may be several different types here. First A means address. Type NS means name server. And the type C name means canonical name. That means original name, full name. And type is MX. In that case, this is a mail server, mail exchange. And here, let's look at this one first. If type is A, then value is IP address. And the name is holding host name. That means the domain name, URL, for example, domain name, thus this one is holding that. And this value is IP address. Thus type A means this about this value. If this is IP address, then type should be A. If this name is domain, and for example, like this, here this name can be host name, also domain name, but this one is domain name, for example, like this, then that value should be host name of the authoritative name server. There's the authoritative name server, as we learned. That information is here. And this authoritative name server, this one is holding that information, IP address, and so on, about this domain name. In that case, this type should be NS. NS means, as I mentioned already, name server. And if the type is CNAME, then C means canonical. Canonical means the real and original name, full name. And the name is alias name for some canonical name, like this. This one is alias name instead of canonical name. There is another canonical name for this. This one is a simplified one. And this one is the full name, and this is called original canonical name, the real name. And it is not easy to remember, to memorize this one. Instead of this, World Wide Web, www, this is more simplified and easy to remember and to memorize. Here, that value, that is canonical name. And the final one, this one is MX. Then value is name of mail server associated with that name. Thus we can see here, this value is different depending upon the type. Please remember that. I may ask in the quiz or in the exam. Okay, this one is about the protocol messages, and to ask and to reply, call and reply, both with the same message format. And here This one is identification, and this one can be 16-bit number for query, and the reply to query is the same number, and to response to that. And this one is flags. Whether this one is query or reply or recursion desired or recursive is not available, that reply is all authoritative, like that. This flag is showing that information. And how many questions, how many answers, and how many authority resource records, and how many additional resource records. Those are explained in next slide. Questions are here. Depending upon that question number, how many questions here, and answer depending upon that number here, the answers, the number of resource records are different. Also, this one is different depending upon that number, and additional resource record. This one is showing that number here. Thus, this one is variable. Okay, this one is still explaining the same format, and as we learned already, this one is for query, and this one is for the response and answers, resource records. This one is authoritative servers for that. And this one is additional helpful information. And how to insert that the resource records into the DNS server. And this one is one example. Let's assume this one is a new startup company, and this company needs to get one domain name. Thus, that should be registered first, and during that registration, and that registration will be done in that DNS registrar company, registration company, and for example, Network Solutions and many other, probably in Korea, a couple of tens registration office, registration companies, they are providing that service for their business. Anyhow, that name should be unique in the world. Thus, in that the registration company's website, that should be checked first before registration. And this one is providing names, IP addresses of authoritative name server. Here, when we are doing that registration, we should provide the primary and the secondary, and list that DNS, authoritative DNS servers IP address. And also we should pay, for example, every year around $20. That is different from registration company to registration company. And here registrar inserts 2 resource records into this .com TLD server, that is distributed database .com top level domain server, and that fee is registration fee to record in that database. There's that information here, networkutopia.com, and that is the DNS information, because this type is NS, and the IP address for that, this host DNS1 host name, and this is domain name, and this A means host name's IP address, this value is IP address for that. Thus we are providing this one. Then this registration company is providing this service, and this registration company is receiving that fee. As I mentioned, to register one .com domain, that is around $20 in US dollar. And after that, we need to create authoritative server and type a LEC code for that, for this one, and later for mail, and we need to provide this LEC code, MX LEC code for mail service, and that is called DNS server. And that DNS server is maintained and administered by this new company. And that registration company also providing that the DNS server, authoritative name server, that is a kind of services provided by that the registration company. Thus we can use that DNS server instead of ours. If we don't have any other DNS server, then we can use that registration company's DNS server, and that DNS server can be used as an authoritative name server for our company's domain name. And let's look at some other issue, because this DNS is so important. There's, in terms of security, they may be attacked by bad guys. One attack is called Ddos attack. D means distributed, and DOS means denial of service. Thus, this means distributed denial of service attacks. This one is like a bombarding root servers with traffic, and still until now that this was not successful to date, and because of that traffic filtering. And in the local server, usually that the root name servers information is there, and also .com name servers information is there. Thus, that is not effective until now. Local DNS servers, as I mentioned, local DNS servers cache IP addresses of TLD servers and allowing root server bypass. In that way, this one is root server is safe from that attack. Instead of that top level domain, for example, .com, .net, or .org, or .kr, those top level domains, that servers can be attacked, then that may be potentially more dangerous. And here there may be some ways to attack, for example, intercept queries, and also DNS poisoning, send wrong or bogus relays to DNS servers which caches with the wrong information, and exploit DNS for DDoS. And here to attack, this may be used, send queries with the spoofed source address, target IP. And there may be several ways to attack this DNS server, but still it has been working well. Let's look at this simple web page about our lecture in this URL, domain name youngkim.net. Here you can see some announcement, domain name here, and the syllabus about this lecture, and also some other lecture related materials, PowerPoint here, and the Wireshark Lab PDF here, and also uploaded YouTube. Those are listed here. As soon as I make those contents, then I will upload in this YouTube first. Later, in the Blackboard, in the right time, in each week, that will be shown there. But in advance, if you want to study in advance, then you can refer to those contents in here. Okay, let's move to the announcement bulletin board. If you are clicking this one, then we can move. I will enlarge a little bit. Okay, a little bit more here. Also, for Korean students, just for reference, you can use the Korean character, single character mang. That is the meaning, the network, and that mang.net, that is the URL or domain name to be here. And you can come here directly. Even if you use your smartphone, you can use that worldwide standard Korean or multilingual domain name here. And you can refer to other contents, and the same content will be uploaded, copied and uploaded in the Blackboard. And this one is updated. The previous one will be deleted. But in the Blackboard, the previous announcement will be still there. Thus you can refer to the previous contents in the Blackboard. But most recent updated contents can be referred in this URL and in this announcement bulletin board. Whenever I am updating, then the updated date will be written here. Thus you can differentiate from other contents. Depending upon the date, you can consider this one is updated or not. Okay, here we are trying to go to the supplementary or reference website. Here, that is the URL, shortened URL. If I am clicking this one, we can go to this one. Here, even though that is being used for 6th edition, but still that is useful and meaningful for the 7th edition and later next year, 8th edition. And here, mainly two menus will be referred in this semester. First one is interactive animations. We'll look at some animations related to today's lecture, chapter 2, and the video notes. And let's click this one first. Then you can see chapter 1 and the chapter 2. I introduced already the contents of this chapter 1 in previous slides. And let's look at this chapter 2. This one is introducing HTTP delay estimation as well as recursive iterative queries in DNS, as we learned already, and in the previous slide we learned about this. Let's try to do some review with this one, and let's look at this one after finishing this one. Okay, this one is explaining about the delay estimation. As we learned already, if we want to use TCP connection, then TCP should be established first. After that, some base original HTML document, that file should be retrieved, and that should be brought to here. And after that, the other embedded contents, objects, that can be uploaded depending upon the non-persistent connection or persistent connection. That interaction may be different. Here we are using non-persistent connection. Thus please read this one first, and after that you can choose some optional contents here, and you can see other result depending upon that option. Here this interactive animation visually illustrates HTTP delays for the retrieval of web page consisting of a base HTML page, this one, and the number of objects depending upon that number. If we are choosing other number like this, then the others another objects. And the interactive animation assumes that all objects are of the same size. The user is allowed to make certain choices, including the number of objects in addition to the HTML object and the transmission delay in terms of this is called round trip time, acronym for that. And based on these inputs from the user, the interactive animation shows the total response time in terms of round trip times. Additionally, the interactive animation provides the total response time from the moment of a web page is registered to the time when the complete web page is obtained. After that, you can choose connection type. As we learned already, non-persistent type or persistent, depending upon that. Let's try to use these persistent connections with the pipelining. Then this is the total delay time. It is very fast, and we need this kind of fast response time. This one is persistent connection with the pipelining. And if we are using non-persistent connection, then it will take a long time, like this. First one is connection establishment. TCP connection should be established first. Thus, that is required. And after that, base HTML file and another objects embedded in the base HTML. Those linked objects will be brought to here. And it needs another connection establishment. Thus, redundantly, this one is required. Thus, it is too bad in terms of performance. Thus, we are using persistent like this. But this one is not using parallel. Thus, each one is independently brought from the remote server. If we are using this pipelining at the same time, simultaneously, those objects here, 4 objects will be brought at the same time. Thus, the total delay time will be very short, and that is the fast response time, and which we are expecting to be. Okay, you can try. Also, whenever we are trying to get the object, that object transmission time delay, depending upon the size, the transmission delay may be different, and we can assume with this option, then this one is that 0.5 around time, relatively, this one is 0.5 to transmit the whole file, and it takes time. Thus, it is showing that transmission delay time here. Okay, you can try others. Let's move to the next. Okay, next one is about the recursive iterative queries in DNS. This one is about the DNS. And we just learned about this DNS. Thus, this one is new enough to understand right away. Recursive iterative queries. First, here we can choose. Here, let's read this one first. In chapter 2 of the text, the authors give examples of recursive and iterative DNS queries. These DNS are interactive, animates additional combinations of iterative and recursive queries among 4 name servers. Here, 4 name server. 1, 2, 3, 4. Here, local name server. Usually, that is located in the same geographical area in that institution or in that company. In our university, we have local name server. And this one is storing that mapping information. Mapping information means domain name and IP address for that. We need that one to get right web contents from the remote site, because that protocol is requiring that IP address in advance. Okay, here if we are choosing the enter scenario type, here root name server has the destination IP address cached. That information is stored here, then we can start here, then that information will be retrieved from here, and that will be stored there, and finally this local name server is providing that information. After that we can get the right information. And if we are choosing other scenario here, for example, root name server has the authoritative name server cached here, then this is holding only the information about the IP address and others about this authoritative name server. Then that information will be given to this local name server, and that will be given to this one, and finally that the IP address will be retrieved from this server. That is authoritative name server. this one is in charge of that IP address which we are looking for. And depending upon the local name servers method, as we learned, iterative, previous one was iterative, and depending upon that recursively, this one is providing. Here, if we are choosing recursive way, then this one is providing that authoritative name server information, and that information is in this information, in this authoritative name server, that information will be given to this local name server. And the previous example, if we are using iterative, then this one is given to this one, and this local server will be in charge of that retriever from that authoritative name server, the IP address mapping data, domain name and IP address, that data will be retrieved from this authoritative name server, and finally this one is providing to this client. Depending upon their recursive and iterative, that may be different, but depending upon their same, even though those are different, still this one is providing the same information, because this one is iterative, thus this one is iteratively retrieving that information. And if we are using other, for example, if we are assuming this one is containing that mapping data, then this one is directly providing that. Usually in our real application, in this local name server, many IP address, for example, naver.com, google.com, those are being used by many clients. Thus, this one is being stored there already. Thus, directly that will be given to my computer. Okay, you can choose other option, and you can see the different result.